So today we're going to be looking at the Unit 2B review. Now this is going to be going through everything from Unit 2B, or the second half of Unit 2. First is classify the pairs of angles. That means they could either be a linear pair, so they're adjacent to each other on the same line. They could be vertical angles across from each other in an intersection. But they can also be alternate interior angles, alternate exterior angles, consecutive interior angles, or corresponding angles. So if we look at 3 and 8, both of those are on the same side of the line, but inside. So that would be same side interior. B, 1 and 5. Angle 1, angle 5. They both are in the same location in an intersection, so that has to be corresponding angles. Angle 1 and angle 3 are in one intersection, but across from each other, making them vertical angles. D says 7 and 8. They too are in one intersection, but they're not across from each other. They're right next to each other, making them a linear pair. 6 and 2. Once again, they are in the same location, making them corresponding angles. 2 and 8. This time they're both inside the parallel lines, opposite sides of our transversal, making them alternate interior angles. We have 1 and 3. These are across from each other in an intersection, making them vertical angles. We have 4 and we have 6. Both of them are outside of our parallel lines, opposite sides of our transversal, making them alternate exterior angles. Lastly, you have 4 and 7. 4 and 7 is not actually a relationship that we've mentioned before. But if we think about it, they're on the same side of the transversal and they're outside, so these would be same side exterior angles, which have the same rule as same side interior. They too are supplementary. Example 2, or problem 2. HG is parallel. So we're talking about that segment right there. Remember, parallel means they move the same direction, but will not cross. So there are multiple options. Our options are EF, so that will not cross. AB, which will not cross. And DC, which will not cross. Skew. Skew, remember, means that they go in opposite or different directions, but will not cross. So we have some options. There are our options. So we could say AE. Notice on how those will not cross. Could say BF. We could say AD, so that diagonal bit, or BC, that diagonal bit. Last but not least, perpendicular. Perpendicular, remember, means they make a right angle. So our options for perpendicular, we could say HE, we could say GF, we could say CG, we could also say DH. All of those would be perpendicular. Now, on your assessment, you're only going to need to be able to name at least one. If you could name all of them, that would be good too. 3, a proof. Given GH is parallel to, or G is parallel to H, and angle 1 is congruent to angle 2, prove that P is parallel to R. Again, that means converse. So we put that note off to the side. Our first statement is our first given. So G is parallel to H. Reason is given. Well, because we said parallel, and I'll even show that on our diagram. G is parallel to H. We can figure out what relationship to use. We can use alternate interior, alternate exterior, corresponding, or consecutive interior. So let's look at this bottom transversal. Looking at it, there's only one angle on it, so we probably can't use it. However, looking at our other transversal, has 2 angles on it. So let's state that relationship between those 2 angles. That means angle 1 is congruent to angle 3, because that relationship is corresponding angles. Always, after a parallel, try to figure out what relationship we're going to talk about. That's the only relationship that we can see, so let's write down our second given. Angle 1 is congruent to angle 2. And that is a given. Came from our given statements. So look at where we left off for both of our givens. Angle 1 congruent to angle 3, angle 1 congruent to angle 2. Because of that, both of them have angle 1 in it, we could say angle 2 is congruent to angle 3. Our reason is substitution, property of congruence, or transitive property of congruence. Remember, the trick is if you combine 2 or more statements, it will pretty much always be substitution or transitive. Well, if angle 2 is congruent to angle 3, that is a relationship that we've talked about before. That is corresponding angles. And if corresponding angles are congruent, those lines have to be congruent. So we can say P is parallel to R because of corresponding angles converse. Again, make sure your last statement is converse because we're proving parallel lines. Number 4. It's a lengthier one. So let's start off this proof by writing down our first given. A is perpendicular to B, is then given. Well, let's check our given to see if there's a vocab, which in this case there is, perpendicular. Well, what perpendicular definition of says 2 lines or line segments that cross at a right angle. Well, I know then angle 1 is a right angle. definition of congruent, or definition of perpendicular. Check our statement now. Do we have a vocab word? Which we do. Right angle. Well, I know the measure of angle 1 equals 90. That is the definition of a right angle. Any more vocab words? Well, no. So let's write down our next given. B is parallel to C. Given. So we said parallel. So those two lines are parallel. Look and see if we have a relationship. We do. Angle 1 congruent to angle 2 because they are corresponding angles. Well, if we look where we left off for the first given and where we are leaving off for this given, there is an issue. The first given has an equal sign, the second one has a congruent sign. Cannot combine them, they have to be the same symbol. So we can say the measure of angle 1 equals the measure of angle 2 because of the definition of congruence. Now they both have an equal sign, so we can combine them. They both have measure of angle 1, so now I know the measure of angle 2 also equals 90 because of the substitution property of equality. It's a POE this time because of an equal sign. Well, what does it mean if an angle equals 90 degrees? Well, that means that angle 2 has to be a right angle, because that is what a right angle means. So angle 2 is a right angle because definition of right angle. And if two lines cross at a right angle, that means they have to be perpendicular. So A has to be perpendicular to C because definition of perpendicular. Next problem. Find the value of x that makes m parallel to n. State the converse you use to justify your reasoning. Well, it just gave you a massive hint. Converse, so we have to use a converse statement. So we can do our highlight trick. We can do zigzag, same color, same value. In fact, these are the same color, so you're going to set them equal. However, that relationship that's shown is alternate interior angles. But we're proving parallel again, even said converse. So we're going to set them equal. 6x minus 44 equals 4x. Now, typically we do get rid of the smaller x. However, if we got rid of that x, it's not really going to help getting x by itself. So let's get rid of the 6x. So subtract 6x from both sides. We get negative 44 equals to negative 2x. Divide both sides by negative 2. And 22 equals x, or x equals 22. Middle one, looking at our relationships, that is a same side interior angle or consecutive interior. And, once again, converse. So if we wanted to do our highlight trick, make our zigzag, different colors, add to 180. So x plus 20 plus x equals 180. Combine like terms, and we get 2x plus 20 equals 180. Subtract 20 from both sides. 2x equals 160. Divide by 2. X equals 80. Last one, looking at our relationships, I can tell that they are in the same location in different intersections. So this would be our corresponding angles converse. If we wanted to do our highlight check, they are in the same color, so we set equal. So x plus 1 equals 110. Subtract 1 from both sides. X equals 109. God, A. Prove alternate interior angles are congruent. We gave you a hint. You cannot use the alternate interior angles theorem. So, we'll start the proof off like normal. Write down our given. P is parallel to Q, because given. Now, because we said that, we need to look and find a relationship. Well, the first relationship that I see is 1 is congruent to 3. So we had those two parallel lines. 1 and 3 are in the same location, different intersections, so that is our corresponding angles. So let's look for another relationship. Also notice that 2 is congruent to 3. They're in the same intersection across from each other, so those are vertical angles. Now notice on how both of our statements has an angle 3 in it, so we can say angle 1 congruent to angle 2. Substitution property of congruence. We combine two statements. Part B is a fill in the blank. Our first one will forever be given. So we said parallel. Well, let's look at relationships then. 1 and 2. Well, 1 and 2 are congruent because they are vertical angles. Two is congruent to 3. Those are in the same location, different intersections, so this is our corresponding angles. And 1 is congruent to 3. Yes, that is a relationship, but if we look at our proof, they both have angle 1, so we're combining things, so this is our substitution or transitive property of congruence. Last one. Oh, 2 more. What postulate or theorem proves that A is parallel to B? So we're going to look for our congruency marks, which are these arcs. So let's look. What is that relationship that is being shown? Those two angles are congruent. Well, same location, different intersections. So this would be our corresponding angles. But it once again proves that A is parallel to B. We have to say converse. Once again, in B, we're going to look for our arcs. I'll just color them in. That relationship would be alternate interior angles. Once again, proving parallel, so converse. Now, last one. Find the value of x, then state the postulate or theorem you use to support your answer. Well, one thing that I notice, we have these arrows on both of the examples. So we're given parallel, so we're not going to use converse. So if we do our highlight trick, same color set equal, these are not the same color, so these have to be supplementary. So 2x equal plus 68 equals 180. So we're going to solve this problem by, subtract 68 from both sides. By doing so, we have 2x equals 112 divided by 2. X equals 56. So we did the first part, we found x. Now, the second part is stating the postulate or theorem. Well, the relationship between those two angles are consecutive interior. Or same side interior. Once again, I'm not going to put converse because the diagram has the parallel lines. Last one. Highlight our zigzag. They are in the same color, so we're going to set them equal. So 2x minus 4 equals 92. So we're going to add 4 to both sides. 2x equals 96 divided by 2. X equals 48. And once again, we need to state our postulate or theorem. In this case, the relationship is alternate exterior. Once again, not going to say that they are converse because the lines said that they were parallel.